So let's have a quick look on that part. Okay, so we are using Windows machine, right? So let me start a Windows machine. Let's do it on Windows first Linux, and then we can go for Windows one. Okay. Just give me 1 second. And okay, my drives aren't connected. Okay, it's should be working now. Okay. So let's start with Linux, and then we'll show it in Windows. Okay. Hit enter. And we need one note here. So we'll have that page. Available to us. Okay, let's have a quick introduction on protocols. So protocols are basically a set of rules, right? That defines how the communication will work. Okay. So who defines that thing? So let's talk about the common protocols that we use in our daily life. The internet protocols. Okay. So let's do a common protocols here. Okay. So for web or using website, we use protocols. So first we use it HTTP, right? Then we have HTTP, HTTPS, right? Then we have a different one. This is going to be the email, right? We use SMTP, POP, IMAP. Okay. And let's do remote. Okay. So we have SSH and RDP. Then we got Telnet, FTP. Let's have that one, these first. Okay. So now look into these things first. All right. Again, if you want to read about these protocols, you can always go to a web browser, type the protocol name, and just type RFC for reference paper. And it should get into this RFC paper. Okay. Or you look into this w3.org website as well. Now this will explain you what HTTP protocol is and how it works. Okay. So this token has been first. Let's try this. This does not exist. Let's search for this RFCs. Okay. All right. So we can get that one. So this is going to the first paper that is written on June 1999. Right. And this is HTTP protocol or hypertext transfer protocol. version 1.1. Okay. There's introduction, there's a purpose. So look into that. So this is the application level protocol for distribution, collaborative, hypermedia information systems. Okay. So the common or the internet we know now mostly runs on HTTP protocol. All right. And the protocol, when it was designed to share information. Security wasn't a concern on that time. All right. Because in earlier days, the website we had doesn't had any kind of dynamic functionalities or any kind of, functions where as a user you can interact with. So because you're just reading a web page, there was no need of security because no one thought of that. Right. Now, in modern web application, every single application have different technologies built in. It could be for data tracking, right? It could be for cookies, it could be for privacies, it could be for the website functionality itself, because now websites are more dynamic and function rich. But in core, we're still using HTTP protocol. So there are terms and conditions you can go through. We don't need to look into all those things, but we will look into some information though. Let's look into method. Here it is. So there are a few HTTP methods. So you get options, get, head, post, put, delete, trace, connect, and extension method for the tokens. Okay. And then if you search for status code, and there is a dedicated page for that. Let's go all the way up. Okay, here it is. So this is the status code that is already defined to some functionalities. So we have 100. So 100 is basically stands for anything that is in 100 is for information. 200 stands for a success codes. So if anything runs successfully, we'll get that code. 300 is designed for redirect, 400 for client error, and 500 for server error. And there are a few status code we can see it here. Right, so it's mixed up here. So you got 100, it's continue, 101, switching between protocols, right? 200 is okay, 201 created, 202 accepted, right? 203 non-authoritative informations, no content, reset content, right? Partial content, multiple choice, move permanently, 302 found, 303 see other, 304 not modified, 305 use proxies, right? Now these are the informations that gonna help us a lot. Okay. Then in request field, we have some other options like accept character sets, accept encoding, accept language, authorizations, and other settings. Now where we can see these things. So let's open up a website. And before I do that, I'm just right click here, go to inspect. So I'll have this developer tool in sidebar. Usually this goes on bottom. I just change these locations to right. Okay, just put it anywhere you want. Okay. By default, it will look like this. I just moved into this side. So that's there. We'll do google.com. And we see we got some traffic here on this side. Right. We see some status code here. Right. Then we see the method, domain name, the file, initiator, type, and some other information. Right, so currently we're looking into status and methods. So it's 200, it's okay. We can click on that. And let's open up the header page for us. So you can see we're sending a GET request on HTTPS for google.com, right? We're getting an address. It's IP version 6 address because it's on hex numbers. Okay, the status is showing me it's 200 okay. The version of HTTP we're using is HTTP version 3, right? And the data we have transferred is 36.29 kilobytes. And then some response headers. So we got cache control, content encoding, right? We have some set cookies and some request headers also. So accept encoding, right? Accept languages, right? And some cookies here and some other hosts going back and forth. And then user agent. So user agent tells server like which web browser we are using. So if server has something configured for a specific web browser, it will show us that specific content on here. Okay, and we have some pages that doesn't have any response, I guess. Yep, it just shows us the page. And that is going to be a GET request for the image. And this is something is getting blocked. Right. So this one returns the information, I guess. Yep, nothing. And reason being that is I have ad blocker enabled here. Okay, so ad blocker can block ads and some tracking cookies. All right. So we can actually see what they have blocked here. And we can see blocked in this page is 6. So they have blocked 6 cookies or 6 requests. So you can see count it there. So we can say 1, 2, 3, 4, 5, and here 6. Right. So Google is a little bit more complicated website to look into, but we can see the information. It works there. I do have an IP address. We're just running a web page. So let's check that one out. So look at, just need this IP address. We'll paste it, hit enter. Sending GET request, get a block request. It's on https google.com. So it's network. Is it offline? It's running. Something is not working. Let's fix it out real quick. So this one is running on DigitalOcean. So it might be firewall thing blocking it up. Don't worry, I'll show you how you can do this accounts and fix these problems. Today, this is out of scope. Just want to show you how it actually works. So let's fix it real quick. So networking, firewall. And I don't have port 80 here, so let's add that. So HTTP. See. Now it should be loading back now. Yeah, it worked. So my firewall was blocking that port. It's fixed now. So we can see we sent a request. We got a 200 OK. And then response header is asking for this informations. And this is what we sent. And so we sent, hey, we are accepting text HTML, application XHTML, XML files, image files, and all those things. The encoding we're expecting or we can decode it, is zzip and deflate. The language we are expecting is English US. The connection would be keep alive till the page is downloaded, the host IP address, and then user agent. Okay. So this is what we sent, and this is what we received. Okay. So they're saying me, hey, everything looks good. And the date is showing you this. So this is the date for the server. Our current date is 8:49 a.m. But in server, it's going on 3:18:38. That would be 3 in morning. Okay, and it's a GMT, so it's a 5 hour behind our clocks, 5 hour 30 minute, I guess. Okay. So keep alive will have it for 5 seconds or maximum 100 seconds. If the page is not loaded up, we'll get a request timeout, or a page not found or something like that. And the last modification of this page happened on 3rd of October 2021 on this time frame. And the server is Apache 2.4.41 Ubuntu. So we get all this information just looking into this header. There is an image file and there's a 404 file. So it says, hey, this file is not available. 404 stands for not found. And we can actually read here. It's going to be here, 404 not found. And click on this section. It explains in detail way, like the server has not found anything matching the request URI. No indication is given whether the condition is temporary or permanent. Okay. The 4010 or gone status should be used if the server knows somehow that the file is gone, or else you can use 404. That means this does not exist right now. It might exist in future. It might have been existing in past. Currently, it's not there. So I'm going to just show you 404. And this is 404 for some file. What was the file name? We can actually see it's favicon.icon or ICO. It does not exist. Returns that code. Okay. Now remember, this is a HTTP protocol. So we can actually read these pages, right? Not only using web browser, but also by intercepting the network packets. Okay, the entire communication is on plain text protocol. Okay, and you might have seen, or some people might have talked about, do not send your credentials over HTTP because it's insecure. Right, always use HTTP or look for HTTPS on the website before you send any credentials. Right, but why people tell that? Like, what is the difference? Like, what would go wrong if I send that on this HTTP protocol? Is there something fancy going on? Something is happening. We don't know yet, right? So let's go ahead and find out HTTP and HTTPS one, and then let's switch to a Windows machine, and I'll show you about other protocols. Okay. So first, we have to log in into our Linux machine. It's going to take a few seconds to. So I'll start our terminal. Okay. Now remember, we did that website one. You can actually do it on terminal as well. You just do curl and use dash capital I flag and the website name or the IP address, and enter in this information. Okay. So the server response header is here. If you look into everything, you just do -VV for verbose mode, and it shows you all the headers it's using. Right. So it's trying to connect on curl user agent, and we can actually read these things on our web server. So if I just do SSH on my server and we'll do a tail -f where logged Apache access log. So it's going to print out first last few lines. Okay, so we send this request one more time. The user agent we are using is curl, and we can see it here. Okay. We can actually change the user agent manually and send request on that way and understand how that works. Shall we do that?
Yes, sir.
Okay. So let me just this is going to be dash h flag. Now let's suppose you don't know how to set that thing. You just look man curl. Okay. And scroll a little bit down. Abstract, don't need that. Dash E flag. Where is dash H flag? Can I search for dash capital H? Yep. Now let's do user dash agent. Yeah, here it is. Okay. So we can just set a user agent like this. Okay. So this is going to dash capital A, I guess. I don't say. I just want to do a dash dash user agent and set it on that way. So let's copy this line. So paste that and dash VV. Instead of super agent, we can just make it as CS0921. And we should be seeing that user agent is going as a call. That did not work. I also use dash capital H flag for that. We're still getting from code. Let me just find out this one real quick. We'll do code set user agent. Let's find some. Yes, Stack Overflow is everything. Yeah, it is capital H user agent, and then type it on that one. And that would be on this way. Nope. User curl dash h user agent this. Stack Overflow failed. Modify the HTTPS request. Just show me the command. Let's do that. See if that works. Can do that. Okay, we can. And it blanked out. So if you just do dash capital I, just to print out that. Yeah, that command worked. What we're mistaking here? Carol IP address dash h user agent. And we are using is equal to sign. That would be this. Now if you look back here, We see the user agent now, CEH0921. Okay, this is what we needed to see. And we're sending a head request right now. Okay. So what we can do is we can do dash X and say, hey, we are sending a get request. And we can see we change that as well. Okay. So usually the request we make from browser, it's going to be get request. You're making the same thing, mimicking the same thing with a user agent as CH0921, and it works. Right? We get the information out of it. Now, user agent is sometimes comes very handy. Okay, when you do a tag, you can change user agent based on your need. I do Control C because that's on server. Okay, that is about user agent and how the communication works. How we can see this web page. Okay, so to do that, we're going to use another tool that is Wireshark. Yes, installed. Let's start that. When I start it on ETH0, okay, just hover over there. It'll show you the IP address. We'll type my credentials. This is because Mac does not allow Wireshark to capture packets. It will allow them. So if I send a ping request, I'll do like ping google.com. And we see it's going to ping here. And we can actually read these traffics there. So you can see there's a DNS request. Oh, we forgot to mention DNS in our notes. That's the internet, right? So just go and add a DNS. Because the DNS is domain name system that takes the domain name and then resolve back to an IP address. Right? And we can see all those things in plain text. You can actually open up the request. This is the request we made. The source IP address and the destination IP address. And I just don't need this hex format, so put it down. And we can see here, we're making a static query, and the flag one is set to that. Okay, so DNS does resolve queries on multiple ways. And the most common and faster way is recursive or recursion. Okay, so if I know the answer, okay, the DNS will ask me, and if I know the answer, I can give them the answer. If I don't know the answer, I'll ask the second person or next person if he or she knows the answer. I got the answers, or it goes gonna move on that way. Okay, I'm gonna talk about DNS in much more detail in next session. Okay, so let's do it today. Let's make a page here. I call them as DNS. Okay, so the entire internet works on DNS. The first thing we have is dot. Okay, and we call them as a parent root. Okay, and after that we got other things, right? So for example, we got .com, right? .in, and let's take other one. We'll make it as a .gov. Okay, let's suppose then again we have a domain name google.com, right? And google.com will have again mail.google.com, right? So here dot is the parent domain. Then we got google.com. This is the domain that we purchased, right, from registrar. And before we do that, we need .com or com itself. Okay, so this is going to have a register. And com is actually owned by VeriSign. So how I know that? Just go to Google and just search for com. And it runs com is owned by VeriSign. This is a registry. Okay, so domain name is .com is top level domain in the domain name system of the internet. Added in 1985, its name is derived from the word commercial, indicating the identity, blah, blah, blah. Registry is VeriSign. Okay. And you can look into VeriSign. It have multiple top level domains registered to them. Okay. So we go just to top level domains. And it owns .com, .net, .tv, .cc, .name, and some others. Okay. So .com is owned by VeriSign. Okay. Google.com is owned by Alphabet. Right. That's a Google's parent company. So Alphabet owns access to Google.com. So that will set an NS record, or we call it as a name server. SER, ER, and it will set a SOA records that are going to be startup authority. Okay. Now, why anyone requires these records? Okay. Currently, no one knows who have the Google.com. So Google.com will tell VeriSign like, hey, this is the name server. If someone asks about me and you don't know the answer, look into these name server or this DNS server. Okay, and this will tell you where is mail.google.com, where is photos.google.com, and all those things. Okay, and SOA record is Google will tell, hey, I have 3 or 4 DNS server, but this is the one that you should trust first. Okay, so let's find this information real quick. We can go back to our terminal and run another tool. It's called DNS utility. We'll dig on google.com. Okay, and google.com returns this IP address for us. Right. Now let's suppose you look into SOA record. You just go to Google. Of course, Google is everything. And on the dig and then show SOA record. And I do not see the website coming up in front. Oh, here it is. So what's the DNS SOA record, startup authority, and this stores important information about a domain name. Okay, like such as email address of the administrator, when was the domain last updated, or how long the server should wait between refreshes, and all other informations. Right. So it's going to have some informations like this, like record type, primary name server, the admin name, the serial number, the refresh timing, retry, expires, and time to live. Okay. It's not showing me that information, how to look into those protocols. That's a bad thing. Dash B address, file name, port queue, DST type, dash X address, 46. No search, no VC. This is just a basic flag. Now let's try typing SOA after that. So print on that. Yeah, it does. So we can see google.com. It's IN stood for internet address, the startup authority. It says, hey, ns.google.com is the primary DNS server. The email address is DNS admin. And the first dot will interpret as @ symbol. Okay, so it's DNS admin @google.com. Okay, and then the serial number, how frequent it's on refresh, timeout, and time to live. And everything is on seconds. Okay. So you can run this command. You can do txt. It will show you the text records for DNS. And before we jump into that, let's go for our DNS record things. So I'll go back here. Okay. So we'll just go here and make it as a DNS records, right? So first we have a record. It's IP version 4. Okay. Then we have quad A. This is IP version 6. Then we got TXT. It's going to be the text records. Right. Then we got SOA. This is the start of authority. Then we got MX for mail exchange server. Okay. Then we got CNAME or conical names. Okay. It maps domain to domain. Okay. So it mapped name to name. Okay. Then we have A record, quad A, TXT, SOA, MX, PTR, or pointer record. Okay, that do the reverse. It maps IP to domain. Okay, so DNS basically do the forward zone. So that is domain to IP. Pointer record does the reverse. It maps IP to the domain name. Okay, and you can actually Google around on DNS record types and get more on that. So just like DNS records. Now let's go to Cloudflare. So you got A record, quad A, CNAME, Amex, TXT. Oh, we missed ANS record. So that is the name server. That is the name server. Okay. Now this is the DNS that holds all the records. Okay. Do we miss anything else? SOA. Oh, SRV records or service records. Okay. So let's go SRV and call them as service reports. Okay. Now we can actually refer that to our reference page. Reference, we're going to put it here. And I need one more for reference. So I'll go back here. That is going to be from this one. I guess so. Yeah, we need this one. And one from Google. So support.google.com. Okay. We have 3 references to go through. Okay. And this is about our DNS queries. So we've got parentroot.com, google.com, and mail.google.com. Now to maintain these things, we have something called root servers. Okay, so we'll just go here, we'll do root DNS servers. So there is a 30 root DNS servers. Okay. So let's go and copy that map real quick. So let's go here, we'll do root dash servers. And that is going to be rootservers.org. We're going to open up this one real quick and INA. One of them have a good map. This one just have IP address. We don't need that. Yeah, this one. So let's make it a little bit bigger so I can copy the map. Okay. We'll do save to clipboard. Okay. I'll take the website and point it to our reference. There. Okay. So these root DNS servers actually runs the entire internet. Okay. So you can see in India, we have 58 on different locations, right? So we got something in Mumbai, something in here, like something in Nagpur, something in Hyderabad, and with some different routes. So F and E. So F is maintained by a different company, E is contained by different companies. We can actually look into those by looking here. F is maintained by Internet System Company, and E is owned by NASA, EMS Research Center. Okay. So these DNS servers holds all the records. But you never heard these names before, do you? No one talked about that, correct?
No, sir.
Yes, because we really don't care about these things, right? What we actually care about, you might have heard about quad 8s or quad 9s or quad 1s, right? So those things also known as open DNS, right? So the common open DNS you know about is dns.google. I hope so, right? So Google own their own things. So just call it as dns.google. I don't know why it's just making it caps. Okay, then Cloudflare have one. So this one have 1.1.1.1. Great. So let's go and add the page after that. So it's going to be quad 8 and 8844. Cloudflare owns quad 1. And you got IBM, I guess. It's quad 9. It's 9.9.9.9. I guess so. IBM or something else. Let's check it out. So we'll do quad 9. Yeah, it's quad 9.net. My mistake. Okay. So it's IP version 4 is that, and then you have this IP address. Okay. So what this OpenDNS does, it holds all the records for us. Okay. And then we can query from these website or these DNS servers and get results on that way. Okay. And these are not actual root server. You cannot update records here. It's just the OpenDNS, and they can do the recursive queries. Okay. So recursive query means dns.google will search the entire internet, record all the databases into their database or DNS server. So the moment we make a query to dns.google, it knows where to find those information. Same with Cloudflare, same with IBM, same with any other companies. They do the same thing. Let's change it to quad 9s. Okay. Apart from that, many universities runs their own local DNS servers. Okay. And this actually helps you to connect to internet in faster ways, because you don't have to waste time to query something and get results on that way. Okay, so that's there. I hope that clears out a little bit concept of DNS. And we missed one thing, the mail here, mail.google.com. This is going to be a subdomain, right? And the subdomain is going to maintain by google.com. Right, so it have to update it on Google name server. Then only .com can receive the records, send it to parent domain controller, and from there it's gonna distribute it to all those root DNS servers. From there you can use it. Okay. So when you purchase a domain name, it might ask you, hey, once you update a record, it might take 24 to 48 hours before you start using it. The reason being is it have to replicate all over the internet. But the internet we know is much more faster. And the recent example you might have seen with Facebook that somehow took down their entire ASN block last week, right? So the records can replicate much faster nowadays, but still, if you're using some older or root servers, it might take days before it got replicated all over the globe. Okay. So we're going to look into that when we set up our own domain servers and play with that. Currently, understanding that part should be more than enough. The other protocol we had is HTTP. Let's talk about that real quick. So HTTP is hypertext transfer protocol. Okay, this is insecure protocol. So that means we can read the plain text data. So let's do that. Okay, we have Wireshark running in background. Yes, it's running. We did not stop it. We can open up a web page and we can go to our IP address. So delete that, paste this IP address, and we get this page. Okay, and too much to scroll. Now I just use this filter field and just type HTTP here. Hit enter, and we see all the requests here. So OCSP is another protocol that stands for Online Certificate Status Protocol. So when you connect to HTTPS website, there is a certificate, and that certificate will have an expiry date. And this protocol verifies if the certificate is expired or not. We are not interested into that for today. We are interested into this HTTP request. So you can see we got our IP address to the server. We got HTTP 1.1. Right. So this is a GET request. We're sending it to server. We can right click. We'll do follow and do HTTP stream. So we can see this is what we sent. This is what server reported back to us. And this is the web page here in HTML. Right. We can read these things. This was on our page. Right. So if someone is listening into our communication and the transfer happened on HTTP, they can read the information. And that is not it. Remember, there was the image of Ubuntu logo. You can actually see that here. So this is where sending the request. This is where we're getting the response. To open this one up, we can see there is a PNG picture. Okay. We can actually download that picture in our computer. Right. So yeah, HTTP is not that secure though. All right. So we can actually do that. We just click like file. We'll go to export objects. Then go to HTTP. Oh, it's still running. So let's stop it first. And now we can see the picture here. It's Ubuntu logo.png. We can just click on preview and shows us the picture we had there. Right. So sending data on HTTP is not a good idea, right?
Sir, any file can be downloaded like this?
Yes, as long as they're using HTTP protocol or any plain text protocol.
Okay, sir.
Okay. We're gonna look into that. Don't worry. Okay. We're gonna invest 2-3 more days on protocols itself. Okay. So you guys have time for today, a little bit more. Like, can we go up to 10?
So they are having a project review today.
Okay.
That's
Okay. Okay. So let me do one thing real quick, and then we can just wrap it up. Okay. So we know HTTP is a plain text protocol, correct?
yes, sir.
All right. So the same thing goes with other protocols like so HTTP is a secure one. DNS is again plain text, and these are all plain text protocol. Okay. So today is Friday, Saturday, Sunday, Monday. I want to be available from Monday.
Okay, sir.
Okay, sir.
Okay, that would be an issue.
Sir, due to that Navaratri.
Yes, I'm traveling and I won't be available till 23rd. So let me check my calendar real quick. You can do this cool thing with Linux. Just type cal, it's up to calendar. Okay, it's not installed on Kali Linux, but here I have it installed. So I'm traveling on 11th till 22. I'll return on 23rd, 24th, 25th. Okay, so I'll do one thing. I'll take a session on Wednesday if possible. Wednesday is Mass to me, right? It's not possible. I'll try on 15th or 14th or 15th. Okay. Or before that, like Tuesday, if possible. Just to give you the clear idea on protocols, so you can have a practicals to go through. Okay. Meanwhile, just research on these things. Okay. And create your own note about all other common protocols that we use. Like when you watch YouTube, what protocol YouTube uses to stream the videos, right? When you send a text message using WhatsApp, what protocol they are using to send and receive messages, right?
Yes,
Just
sir.
get those information, have it in a note. Okay. So currently, how many protocols we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So just increase the list to 30. So 30 protocols that we use in our daily life. Okay, make your own list. You can collaborate together, no issues. So protocol name is secure or insecure. Why we use that protocol? That would be more than enough. Okay, and then we're gonna look into your protocol list. I'll complete my protocol theory. Now, insecure protocols, why we should not use that. We'll look into your protocols, and then I'll assign you a task. So you can complete on the next week after Navratri, and then we'll jump back to our topics.
Okay,
Sounds
sir.
good?
So 30, so 30
Yes.
protocols.
Sir.
Yes, 30 protocols that we use in
HTTP,
our daily life.
HTTP no, sir. Or,
HTTP is already there.
okay, sir.
Okay. So you can look into WhatsApp or Telegram or any other application, what protocol they're using.
Sir, excluding all these three, 30 protocols.
Now you can add this one as well. So you have to find 20 only.
Okay.
Okay. All right then. So have a great weekend and we'll
So
see
our
you on
next class is on Wednesday, right?
Wednesday is Mahastami. That day I won't be available. So I'll try on Tuesday if possible. I'll update you on WhatsApp.
Okay, sir.
Okay, sir.
Okay. All right then. So have a good day. Continue with that. And if you get any questions, just drop it on WhatsApp. So I will be there to look into that. Okay.
Thank you, sir.
Yes.
Okay.
Yes.
So this was the command like cal1. So it's print out calculator. Oh, sorry, calendar on your terminal. Okay. So nice little tricks to do make your life easier with command line.